Hello everyone and welcome. Today we are diving into the world of quadratic equations and their roots. Now, don't be intimidated. We are going to take it step by step. First, I will explain what quadratic equations are and then we will work through some problems together. When we get to the practice questions, pause the video, grab your pen and try them out. After you have given it your best shot, we will go through the solutions together. By the end of this session, you will have a much better understanding of a quadratic equations and how to find their roots. So let's get started. You know that the quadratic equation is written in this format: ax squared plus bx plus c. What is a? A is the coefficient of x squared. And what is b? B is the coefficient of x. And what is c? C is the absolute term. How can we get the two roots of this equation? By using the general formula. You know, the general formula x equals negative b, positive or negative the square root of b squared minus 4ac divided by 2a. And some students get confused asking, where are the two roots? You know, here the two roots, we have written positive or negative in the general formula. So the two roots are x negative b positive plus the square root of b squared minus 4ac over 2a. And the second root x equals negative b negative the square root of b squared minus 4ac over 2a. I have three equations and I wanna use the general formula to find the two roots of all of them. So here, what is a? The coefficient of x squared is 1 and b is 5, c equals 1. Use the general formula to find the roots. X equals negative b, negative 5, positive or negative the square root of b squared, it's 5 raised to the power of 2 minus 4 multiplied by 1 multiplied by 1 for ac, all divided by 2a, 2 multiplied by 1. That is going to be equal to negative 5, positive or negative the square root of 5 raised to the power of 2 is 25 minus 4 times 1 minus 4 all divided by 2. So that is going to be equal to negative 5, positive or negative the square root of 21 over 2. Now we have two solutions. By using your calculator, you can find them. X equals negative 0.21 to the nearest two decimal places, and x equals negative 4.89 to the nearest two decimal places. We observe that the two roots are real and different. So the two roots here, real and different. The two roots are real and different. Here in this equation, we observe that this equation can be factorized, but I want to use the general formula to find the two roots. So x equals negative b, negative 6, positive or negative the square root of b squared minus 4ac, it's negative 6 raised to the power of 2, minus 4 multiplied by 1, multiplied by 9, all divided by 2a, 2 multiplied by 1. So x equals 6, positive or negative, the square root of 36 minus 36 is 0. All divided by 2 times 1, 2. We have two roots now. The two roots, they are the same. It's 6 plus a square root of 0 over 2, and 6 minus the square root of 0 over 2. And as you know, the square root of 0 is 0, so there is no difference between plus root 0 or negative root 0. So the two roots are going to be equal. So here we have 3 and here we have 3. They are the two roots. So the two roots are real and equal. Two real equal roots. Here in this equation cannot be factorized, and I told you to use the general formula. So x equals -2, positive or negative, the square root of b squared, it's 2 raised to the power of 2, minus 4ac, 4 times 1, multiplied by 4, all divided by 2a. So here x equals -2, positive or negative, the square root of, here we have 2 to the power of 2 minus, it's 4 minus 4 times 1 times 4, it's 16, all divided by 2. So it's equal to -2, positive or negative. 4 minus 16, it's -12, all divided by 2. So there is no real roots for this equation, but we have two complex conjugate roots. Why? Because we have -12 here. So the two roots are going to be x equals -2, positive or negative, the square root of, we can write -12 as 12 multiplied by -1, square root of -1, all divided by 2. So it's -2, positive or negative. Square root of 12 is 2 root 3, and the square root of -1, it's I, all divided by 2. So we have two roots, two complex conjugate. It's -2, the first one, it's -2. Okay, because we don't have much room here, so it's -2 plus 2 root 3i over 2. This is the first one, and the second one is -2 root 3i over 2. So what I wanna say here, look at the expression written under the square root, b squared minus 4ac, here, here, and here. Okay, the discriminant here, this expression is called discriminant, and the discriminant is the expression which determines the types of the two roots. So here, 5 to the power of 2 minus 4 times 1 leads to get a positive value here. It's 21. So the discriminant here is positive, and the two roots are real and different. In the second equation, the two roots, the discriminant is equal to what? 0. And the two roots are real and equal. And in the third equation, the discriminant is negative, and the two roots are two complex conjugate, as you see here. Two complex conjugate. Okay. So what is the discriminant? The discriminant is a simple mathematical value that helps us understand the nature of the roots of a quadratic equation. And the discriminant is calculated using this formula. It's b squared minus 4ac. So the discriminant is the expression under the square root in the general formula. The discriminant is b raised to the power of 2 minus 4ac. Again, once again, what is the discriminant? Is this expression written under the square root, it's b squared minus 4ac. Okay? Types of the discriminant. If the discriminant is a positive discriminant, that means b squared minus 4ac is greater than 0. The discriminant is positive. If the discriminant is greater than 0, it means the quadratic equation has two real and distinct roots, as you see here, real and distinct roots. If the discriminant is positive, okay, so the equation has real and different roots. The equation has real and different roots. In other words, the graph of the equation intersects the x-axis at two different points. Intersects the x-axis at two different points. So here we have 2 points, point 1 and point 2, and here we have 2 points, point 1 and point 2. And the curve might be open upwards or open downwards. If the second case, if the discriminant equals 0, b squared minus 4ac is equal to 0. If the discriminant is equal to 0, it means the quadratic equation has two real equal roots, and because the equation has two real equal roots, so we can say the equation has one real root, okay? Because if we looked at the previous examples, you will find an equation like this one, x squared minus this equation minus 6x plus 9. We can factorize it and get x minus 3 and x minus 3. So here the two roots are real and equal. If the discriminant equals 0, the graph of the equation touches the x-axis at a single point. The graph of the equation touches the x-axis at a single point. The third case, if the discriminant is negative. If the discriminant is less than 0, it means the quadratic equation has two complex conjugate roots. Complex roots involve imaginary numbers, and the graph doesn't intersect the x-axis. The graph doesn't intersect x-axis. In summary, the discriminant helps us determine whether a quadratic equation has real or complex roots and how many of each. This way is a hand tool for understanding the nature of solutions of the quadratic equation. So here, once again, we have three cases: positive discriminant, the first case, positive discriminant, the second case, zero discriminant, and the third case, negative discriminant. I want to determine the type of the two roots of the three equations I have here. The first equation is x squared plus 7x plus 3. So just check the discriminant. The discriminant is b squared minus 4ac. A is 1, b is 7 here, and c is 3. So b squared is 7 minus 4ac. 4 times 1 times 3. It's 49 minus 12. 49 minus 12 is 7 here, and 3 is 37. So we have a positive discriminant. That means the two roots are real and different. Real and different roots. And here, what is the discriminant? Is b squared, it's 8 raised to the power of 2 minus 4 times 1 times 16. So it's 64 minus 64 equals 0. So the two roots are real and equal. The two roots are real and equal. And here b squared, it's 3 to the power of 2 minus 4ac, 4 times 1 times 5. So it's 9 minus 29 minus 20 equals negative 11. So the discriminant is negative. That means that the two roots are two complex conjugate. to complex conjugate roots. So to determine the type of the roots without using the general formula, just check or find the value of the discriminant, and the discriminant is b squared minus 4ac. And be sure that the equation is written in this format: ax squared plus bx plus c equals what? Equals 0. This session was a conceptual introduction to quadratic equations and their roots. I hope you found it helpful in building a foundation for your upcoming sessions. Stay tuned for our second session, where you will dive even deeper into solving quadratic equations and exploring more complex scenarios. See you in the coming session. Goodbye.